this lesson, I'm going to take the concept of oxidation and reduction and I'm going to apply it to voltaic cells. Now, voltaic cells, in a voltaic cell, an oxidation and a reduction reaction occurs. And the cool thing about the voltaic cell is that because the oxidation and reduction reactions are separated, you can actually see the flow of electrons that can actually power a battery. So let's look at it. We're going to start on the left-hand side. What happens in a voltaic cell, you start off with a metal, a solid metal, for example, zinc. And so zinc is going to give up its electrons to become a zinc ion. Now, where those electrons go is that it's going to flow through that wire all the way over to the copper side. Now, really quickly, just to make sure we're clear, the zinc ions go into solution. Now, as those electrons hit copper, what happens is that the copper ions that are in solution, those are going to pick up those electrons to produce solid copper. So there's going to be more and more and more copper atoms being added to the copper bar that you see right there. So while you're losing zinc solid, you're gaining copper solid. Now, the reason why it's that way, we'll look at some values and some mathematics. But for right now, just accept that oxidation happens on the zinc side and for copper reduction, and we'll come back to it, I promise. Now, a couple of other pieces of information that I need to include. The first one is wherever oxidation occurs, that's called your anode, and the way that I remember it is because those are both vowels. Wherever reduction occurs, that's the cathode. So notice zinc is being oxidized, so that's the anode, and copper is being reduced, so that's the cathode. The other piece of information that I have not included is what exactly the salt bridge is. So if you look at what's happening, on the zinc side, on the anode side, you end up with more zinc ions in solution. So that ends up with a very positive charge on the anode side. While on the cathode side, you're losing copper ions, which means it's going to have a very, very low positive charge, if not a negative charge. We don't want that. The reactions that are occurring will not continue if you end up with a buildup of charge. So as a result, we have what's called a salt bridge. So that salt bridge provides ions in order to make sure that one side doesn't become too positive and one side too negative. So since there's a lot of zinc ions that are positively charged forming on the anode side, nitrate ions are actually going to be moving in order to balance that positive charge. On the other hand, the sodium ions are going to be moving to the cathode side to balance the fact that you're losing positively charged ions. So the whole point of this is just taking a concept we've already looked at, which is oxidation reduction, and actually being able to measure the flow of electrons.